Okay, now we will go to the interfacing HCS12 with the IP switch. So how do we connect the IP switch to the Dragon board? So look at this diagram. We will use 8 switches, okay, and will be connected to the port H. So all port H are used for connecting to the IP switch. And then for the switch, we will go to the ground, and then we will connect to the port H, and then in parallel we will have the resistor and VCC. And how do we program to use the IP switch as a controller? Okay, for this example, we will write a program that will turn on all LEDs at Dragon board if only one of the IP switch is used. So instead of 8, so we just use only one IP switch. Okay, so what we have to do first, we have to configure the pin direction. So for LEDs, we will use port B and port J1. So all port B are used, and only port J1 we will use for ground, and only one pin port H will be used. So to get the value, we will do the table. Okay, first for the port B, all are used for output. So we will give every pin to high. Then we will get 1 1 1 1 1 1 1 1, so FF. So we will give instruction move by FF to the DDRB. And port J1, because we just only J1, so we can use bit set or bit clear. Because of our output is 1, so we have to use bit set. Okay, bit set DDRJ, and the position is 0 0 0 0 0 0 1 0. 1 determine the position, so J1. So we will get 0 2 0 2, and same as port H. So let's say we want to use H0 as input. H0 as input. So because we want to make the switch, so we will use bit clear, okay, because input is 0 bit clear, and DDRH, and the position is 0 0 0 0 0 0 0 1. So 1 is the position. So who get the 1? So H0. So let's say if I change, I don't want to use H0, let's say I want to use H4. So I can write 0 0 0 1 and 0 0 0 0. So H4 will be my switch or input. Okay, and then the condition, if H0 equal to 0, turn off all LEDs. If H0 equal to 1, turn on all LEDs. So if you have certain bit to be the condition, so you can use branch set or branch clear. So either branch set or branch clear. And then if we want to turn off LED, just move by 0 to port B, and turn on all LEDs, move FF to port B. And for J1, you have to ground, bit clear, PTJ 02. So this is overall program. So first we configure the port. So the green one is just for configuring the pin directions, either it is input or output. So port B, port J output, port H input, and then to enable the LEDs to be turned on, so port J1 must be ground, and just initialize, all LEDs must be off. Okay, and then we go to the condition. So let's say we put branch clear. Branch clear is actually asking the condition. So is the port H, so we don't know what is inside port H, and then we have to end with 0, 1. 0, 1 is a must. We have to end, and then 0, 1, the position is at H0. So we will ask either H0 equal to 0 when we get the result here. Okay. Then if 0, we will go to the off. So we go back to here. If not, we will turn on the LED. So next instruction is execute. Just branch clear is just to do a end operation between port H and the mask 0, 1. And then the question is, we look at the 1 position 1. 1 is at H0 or bit 0. So is the answer after you end, you get the 0. Okay, here. So that is the meaning of branch clear. So let's say, for example, you have port H. You have 0, 1, 0, 1, 1, 1, 0, 1. And then you will end with 0, 0, 0, 0, 0, 0, 0, 1. So this is end operation. So 1 and 1 is 1. The rest is 0 lah. So 1. So the question is the bit 0 equal to 0? No. So if no, it will turn on all LEDs. So that's mean the port H0 is 1. So you turn on the LEDs. Okay, same. Okay, that is the function of branch clear, and same with branch set. The difference is branch set. It will ask either the end result is equal to 1. That's all.